Students, in this video we are going to study the deadlock prevention. So in last video we have studied the conditions or the characteristics of deadlock. Okay, so now how you are going to prevent the deadlock, that is nothing but the deadlock prevention. So it is very important to prevent a deadlock before it can occur. Okay, so every time the system is going to checks every transaction before it is going to be executed. Okay, so why? So we have to make sure that there should not be a deadlock occur. Okay, so again, so already we have studied the characteristics or the conditions of a deadlock. So we have to eliminate those 4 conditions of deadlock. So which are the 4 conditions of a deadlock? That is mutual exclusion, hold and wait, no preemption, and circular wait. So first we'll study how you are going to eliminate the mutual exclusion to prevent a process from deadlock. Okay, so first one is the mutual exclusion. So in mutual exclusion, the mutual exclusion, what do you mean by mutual exclusion? We have studied. It means no two processes can use the same resource at the same time. Clear? So now no two processes or more than 2 processes can access or can use the same resources at the same time. So if it does so, then that particular process is going to be fall in a deadlock. So how you are going to eliminate the mutual exclusion? So already the mutual exclusion must hold for the non-shareable resources. Okay, so it must hold for the non-shareable resources. For example, a printer cannot be simultaneously shared by several processes. Clear? So non-shareable resources means what? We cannot share for example, we cannot share a printer at the same time for the different processes. So hence the mutual exclusion must hold for the non-shareable resources. For example, a printer cannot be simultaneously shared by the different processes. So now what about shareable resources? So shareable resources means for shareable resources it does not require the mutual exclusion. Why? As we have studied in the last video, the read-only files are the good examples of a shareable resources. So if several processes attempt to open a read-only file at the same time, then they can be granted simultaneously to access that read-only file. So here the mutual exclusion is not going to be happen. So hence we can prevent it from the deadlock. So we cannot prevent the deadlocks by denying the mutual exclusion condition, because some resources are naturally non-shareable. For example, a printer here. So shareable and non-shareable you have to remember here. So as I have mentioned on a screen here, mutual exclusion must hold for the non-shareable resources. So non-shareable resources means what now? For example, a printer cannot be simultaneously shared by the several processes at the same time. So what about shareable resources here? For shareable resources it does not require here the mutual exclusion, and it cannot be, and whenever we are using the shareable resources, the processes are not going to be fall in a deadlock. You have to remember here. So for example, the read only files are the good example of a shareable resources. So if several processes attempt to open the read only file at the same time, they can be granted here simultaneously to access that read only file. Okay, so but we cannot prevent here the deadlock by denying the mutual exclusion, because some resources are naturally a non-shareable resources. Clear? So this is the first condition how you are going to eliminate the mutual exclusion to prevent the deadlock. So second is hold and wait. So now to ensure that the hold and wait condition never occurs in a system, then we have to guarantee that whenever a process requests a resource, it does not hold the any other resource. So hold and wait means what? A process is going to wait for resources while holding the another resource at the same time. So we are holding the some resources and still it is waiting for the some other resource that we have to uh, hold here. So now this can be done in a two ways. So first one, I will call it as the first approach. So there is a first approach. So in the first approach, a process has to first request for all the resources. Okay. So in the first approach, how you are going to eliminate the hold and wait? There are two approaches. Okay. In approach 1, in this first approach, a process has to first request all the resources whatever it required for the execution. Okay. So once it got all the resources, or once it has acquired all the resources, okay, from the computer, then only it is going to start its execution. Clear? What do you mean by this first of what it is going to do in a first approach? A process is going to first request for all the resources whatever it wants for that particular process execution. Once it has acquired, or once it got all the resources from the computer, then only it is allowed for the execution. So now by doing this, we are going to ensure that the process is not going to hold the any resources and it cannot wait for the other resources. So by doing this, again there is a certain drawbacks or disadvantages. So what is the drawback here? The low resource utilization. So how the low resource utilization is going to be happen? For example, consider a process. For example for the approach 1. So consider a process. So in that process, what that process is going to do now? A process that copies the data from the DVD drive. Okay. A process is going to be copies the data from a DVD drive to a file on a disk. Okay, it copies the data from DVD drive to a file on disk, and it is going to do the sorting. It sorts the file, and then later it is going to print that file, okay, by using the printer. So here if all the resources must be requested at the beginning of a process, then the process is going to be initially request the DVD drive and then disk file and printer. Okay, here it is going to copies the data from a DVD file, that is DVD drive, to a file on disk, and it is going to print the file on a printer now by using printer. So here if the process starts requesting in the before execution, it has to must initially request the DVD drive, disk file and printer. So at the end of the sorting and all, we are going to use the printer. So it will hold the printer for its entire execution, even though we need the printer at the end. Okay, so here, because the resources are unused for a longer period, so hence the drawback we can say here, the low resource utilization. Got it? So in what is the approach 2 for the hold and wait? So in approach 2, in the second approach, I have written here approach 1 again, but it is an approach 2 here. Okay. So in the second approach, we are going to allow a process to request the resources only when it has none. Okay. It means what? A process is going to first request for all the resources it requires for executions. Okay. Means a process is going to allow to request resources only when it has none. Suppose a process is not having any other resources, then only we are going to give a permission to request for a resources. Okay. So when a process may request some resources, means a process may request the some resources and use them. Suppose I am having one resources, I may use them. Before it can request any additional resources, it must release all the resources, okay, that is currently held by that particular processes. Are you getting? Means what? In the second approach, it allows a process to request resources only when it has none. Means a process is not having any, not holding any other resources, means then only we are giving the permission to request a certain resources. A process may, means a process may request the some resources. Suppose that process is having already a one resources, so if I am already having one resources, I need to use them, okay. So suppose it may have the more addition, or it may have, or it may require more resources to execute the certain task, then I have to request more resources. So after using that resources, I have to release those resources, okay. Now for example, again I will take that DVD drive and disk file example here. So in the second approach, a process requests initially the DVD drive and disk file. So if I initially am requesting the DVD drive and disk file, it copies the data from DVD drive to a disk file. So this is the first request of a resources, that is DVD drive and disk file. So the process again request here the disk file and printer. Why? I need to print a data from the that disk file. So hence it is going to re-request the disk file and printer. So after copying the disk file to a printer, it is going to release the all the these two resources, and it is going to stop its execution. Clear? So by doing this, there is again one more drawback, not the low resource utilization. So by mistake I have written here the low resource utilization. So the drawback of approach 2 is here the starvation is possible. So what is starvation here? Starvation is what here? A process that needs the resources may have to wait indefinitely, okay. There is no time, okay. A process that needs resources may have to wait indefinitely, okay. Infinitely it is waiting for that particular resources. So this is the drawback of this approach. So now next is the no preemption. So in no preemption, the third condition for deadlock is no preemption. The third condition for deadlock is that there should be no preemption of resources that have been allocated. To ensure that no preemption does not hold, we have to follow the approaches. So what is preemption here? Preemption means in middle only we are pausing or we are stopping the process execution. So we have to prevent it. So if for certain reason if we are stopping that particular process execution, that is nothing but the preemption. So if the process is doing that like that, then deadlock is going to be occur, okay. So now, so how we are going to avoid this, okay. So again we have to follow the certain approaches. So in approach 1, if a process is holding some resource and again it is requesting for another resource, then that cannot be so for example, okay, in approach 1, if a process is holding some resource and again it is requesting for another resource and that resource cannot be immediately allocated to it, then all the resources that are currently held by that process are going to be released. Getting? In approach 1, in a no preemption, if a process is holding some resource and again it is requesting for another resource, and that resource cannot be, if that resource cannot be immediately allocated to it, then all the resources that are held by that process are going to be released. Getting? So now when that process wants to once again when that process is going to be executed once again. So in that case the process restarted execution only when it regains the old resources along with the new resources in a single request, not waiting, okay, without waiting for that particular resources. Clear? So in approach 2, in the second approach, when a process requests the some resources and if they are available, we have to allocate it, okay. So if a resource requested is not available, then we have to check whether it is being used. Getting when a process requests some resources, if they are available, we have to allocate it, okay. So if a resource is requested is not available, then we have to check. So what we have to check here, whether it is being used by the different process or whether it is being used by the other process, or it is allowed to some other process waiting for other resources. So if that resource is not being used, then operating system is going to preempt it. Preempt it means we are going to pause it from the waiting process and we have to allocate it to the requesting process. Clear? So if that process is used or is being used by the requesting process, then it has to wait. Getting? So this approach can be applied to the resources whose states can be easily saved and restored, that is by using the PCB, okay, process control block. So in last one is the how we are going to eliminate the circular wait. So to avoid the circular wait condition, the resources, so already we know what do you mean by circular wait. Circular wait is what we are having the set of processes like P0, P1, P2 up to Pn, okay. So now if P0, the P0 is a process and it is requesting for the resources which is held by the P1, and similarly P1 is waiting for the resources which is being held by the P2 and so on. So now to avoid the circular wait, the resources may be ordered. The resources again like that P0, P1, no, again we have to give the resources to the numbers, and we can ensure that each process can request the resources only in a increasing or decreasing order. So whenever we are allocating the resources to the processes, we have to give it in a increasing or in a decreasing order. So in case if increasing order is followed, if a process requires a lesser number resource, then it has to release or it must release all the resources having a large number, and vice versa. Means what? If a process requires a lesser number, if I am following the increasing order approach, if a process requires a lesser number resource, then it must release all the resources having larger number, and vice versa. Means if I am following the decreasing order, means if a process requires a larger number resource, then it must release all the resources of a lesser number. Clear? Thank you.